Welcome back to another past paper walkthrough. This is OCR MEI C2, and this video will be covering the section B part. If you want to check out section A, I have another video posted the other day. So let's get right into section B. So section B, question 9. 1. Jean is designing a model aeroplane, and the figure shows her first sketch of the wings cross section. Calculate angle A and the area of the cross section. Now, she modified her design for the wing into something as shown as the bottom, figure 9.2. And for every unit of x and y, it represents 1 centimeter. And you need to use the trapezium rule with width of 4 centimeter to calculate an estimated area of this cross section. So in this question we need to find A and the area. So since we have 3 different sides, we can use the cosine rule. So 8 squared is equal to 20 squared plus 13 squared subtract by 2 lots of 20 times 13 cosine of A. By rearranging, we can find cosine A. So cosine A, 2 times 20 times 13 of cosine A is equal to 420 squared plus 13 squared, which is 169, I believe. Yes. 169 subtracted by 8 squared, 64. And after you've done the calculation, you divide everything by 2 times 20 times 13. So you get that cosine of A is 505 divided by 260. Well, no, that is times 2, and that would give us 520. So it is 505 divided by 520 equals cos A. So if you apply arc cos to the expression 505 divided by 520, you'll get 0.24 radians. You can choose to work in radian or in degree. In these kind of exams, you are allowed to choose your own angle units. Both are acceptable as long as you keep using the same same mode for your calculator for calculating the area. So now let's look at the area. I'll write AR as area because we used A for the angle. So area of a triangle is half of AB sine C, which is half of 20 times 13 sine of 0.241 radians, and sine of that will be 0.238 times 130, which is half of AB. You get 30.998. Actually, it's a lot of 9s, and therefore by rounding to 3SF you get 31.0 cm squared, and that's the area. Now for second part, we have trapeziums, and we need to use a horizontal distance of 4 as our trapezium height. So we have the upper surface and the lower surface, and there are two different trapeziums. So you can either do a do two of them at the same time by subtracting the lower surface value by the upper surface value, or you can calculate two trapezium rules. And for the purpose of this video, I'm going to combine both of them and do them all at the same time to save time. So y of the first value x0, let's just do the table for now, and the y will be the amended value for y, which is the combination of both of them together. So 1.45 subtract by negative 0.85 will give you 2.3. And actually that is not right, because x0 is 0, x4 is y 2.3, then 1.56 subtracted by negative 0.76 is 2.32. Then we have 1.27 subtract by negative 0.55, which is 1.82. And for x equals 16, we have 1.34, and lastly we have x equals 20, y equals 0. So because we have combined two tables together, we can do just the simple trapezium rule. So the trapezium rule is defined as half of the first value plus the last value plus 2 lots of everything in between. So 2.3 plus 2.32 plus 1.82 plus 1.34. And multiply that by the height. Now the half and the height can cancel to give 2. And since the 0 doesn't matter, just ignore them, and using your calculator, add all the values together. You get 7.78 times 2. And outside that, you have another times 2. This 2 is this 2, by the way. And so the total area is 31.12, which is 31.1 in 3SF. Question 10, we have a curve, gradient of 4x plus 3, and the curve passes through the point 2 and 9. And part 1 is to find the equation of the tangent at that point, and part 2 is find the equation of the curve and the coordinates of intersection with the x-axis or their roots. Also, find the coordinate of the minimum point. Lastly, part 3, find the equation of the curve after it has been stretched parallel to the x-axis with scale factor half, and write down the coordinate of the minimum point of the transformed curve. Okay, so let's start with part 1 and 2. So for part 1, tangent is a straight line, so y equals mx plus c, where m is the gradient, and we know that at point 2, 9, the gradient dy by dx is equal to 4 times 2 plus 3, which is 11. So m is 11 in this case, and by putting in point 2, 9 onto the equation, we get that 9 is equal to 11 times 2, 22 plus c. And by rearranging, we get that c is minus 13. And therefore, the tangents have the equation of y equals 11x minus 13. Part 2, point of intersection of y with the x-axis, or the solution of the solution of y. So what you need to do is integrate this whole thing. And by integrating this by dx, you get y. So integrate y dy by 4x plus 3 dx. This is just simple notation, but if you do not know how this separation of variable thing works yet, I'll cover that some other time. So d of just simply dy will yield you a 1y, and integrating this whole thing by dx will give you 4x squared divided by 2 plus 3x divided by 1 plus c. And we know that this can cancel to get 2, and therefore y is 2x squared plus 3x plus c. Now we need to find the value for c, but because we have the point, this will be relatively easy by just substituting y is 9, x is 2, so this is 8 plus 6 plus c. And that add together to 14, and so c is minus 5. So we get the equation y equals 2x squared plus 3x plus c, and the points plus minus 5, sorry. So the point of intersection is just the if I factorize this and find the solution for y equals 0, then I can find the answer. So let's write 0 equals to 2x factored, and this have to be 1, 5. So it is a minus 2, so I know this is a minus 1 and a plus 5. And this is just normal 1x. So this is the factorized version. And therefore, we know that 2x plus 5 is equal to 0, and x is minus 5 halves, or x is equal x minus 1 is equal to 0, which is x equals 1. So there are the two intersection points. Now, this is not sufficient, and so we need to actually write down the coordinate of the points. So when x is minus 5 halves, y is 0. This is the first point, and the second point is 1, 0. So this will give you 2 marks for the answer. Now I need to also find the minimum point of this whole equation. And we know that a minimum point of a quadratic equation is where the gradient is 0, which is the only stationary point. So dy dx is equal to 0, which is equal to 4x plus 3. And so x is minus 3/4. And we just need to put this back into the equation to get y. So y is, let's see, 2 times 3/4 squared. Because it's a negative squared, it goes to positive, so I ignore the negative sign. Now subtract by 3 lots of 3/4, and I swap the sign for negative, and subtract by 5 again. So that would be 9/8 subtracted by 9/4 subtracted by 5. And that will give you a negative value as expected, because we have a minimum point below the x-axis. So 9 divided by 8 minus 9 divided by 4 minus 5 gives you minus 49/8. And that is our y point, and therefore the minimum point is minus 3/4 minus 49/8. So now we need to find the transformed equation. This is the original equation. And we know in function notation, fx, if stretched by a factor half, goes to f of 2x. And therefore, for this y value, instead of using x, we use 2x. So the new y, let's say it's g, will be equal to 2 times 2x squared plus 3 times 2x minus 5. And that would give us 8x squared plus 6x minus 5. That will be the equation, and the minimum point given above, since it have been stretched by a half, the x value will be changed, but the y value will not be changed. So the x value will be halved, so it is minus 3/8. And the y value retains as 49/8 negative. That is the new point of minimum. Okay, final question of the paper. It seems like some form of a log question. So Jill has 3 daughters and no sons. They're generation 1. And each of her daughter has 3 daughters and no sons. And the 9 granddaughters are generation 2. And cycle repeats over and over again. And Jill decided to investigate what will happen to this pattern. And part 1, how many of her descendants would there be in generation 8? and part 2, how many descendants would there be altogether in the first 15 generations. Number 3 is after n generations, she will have over 1 million descendants, and basically find n in the form of this inequality. And how many fewer descendants would Jill have altogether in 15 generations if she had 2 daughters instead per generation. So since this is a pattern, let's start with doing sequences. So generation 1 have 3 descendants. This is generation 1, 3 daughters. Generation 2 goes to 3 times 3, 9 descendants. Generation 3 have 3 to the power 3, 27, and so on. And so we can deduce that the number of descendants have the general equation of 3 to the n, where n is the number of generations. So we have Gen 8. We need to find the number of granddaughters or great-great-great-granddaughters or whatever in just generation 8. And therefore n is equal to 8. So 3 to the power of 8 is a massive number, which is 6,561 people. And that is part 1. Part 2, I need to find the sum of 15 generations, the first 15 generations. So it is again a sum to 15 from 1 of 3 to the power of n. So in this kind of calculations, we have to consider what kind of sequence is this. So in this case, it is a geometric sequence, and the A, which is the first term, is 3, because generation 1 have 3 people in it. And generation 2 is AR, which have 9, and therefore R rather, the ratio must be 3, which makes sense because every single generation you triple the number of descendants. So the sum for that geometric sequence is A times 1 minus R to the power n divided by 1 subtract by R to the power of 1. So it's just R. This is the sum to n. And at this stage we have sum to 15. And so n is 15. And so the sum is 3 times 1 minus 3 to the power of 15 divided by 1 minus 3. So if you pop that all into the calculator, you get some really ridiculously large numbers, but it all goes down to about 2,152,3,359 descendants, and that is a large population. I'm not gonna bother rounding this now because it's supposed to be kind of accurate, isn't it? So now part 3, when the number of descendants is greater than 1,000,000, we need to find n and express the form in the form stated as the paper. So when the sum of the descendants, which is 3 times 1 minus 3 to the n divided by 1 minus 3 is greater than 1,000,000, we rearrange that so that you multiply both sides by -2. Make sure to flip your inequality sign because you're multiplying by a negative number. So you get 2,000,000 minus 2,000,000 times 3 minus 3 to the n plus 1, because 3 times 3 to the n is 3 to the 3n minus 1. Well, 3 to the n minus n plus 1, sorry. Now rearrange everything so that 3 to the n plus 1 is equal to 2,000,003, because 3 plus 2,000,000 is that. And you log both sides by 10, base 10 log, so log 3 to the n plus 1 is log of 2,000,003. And because of power loss, you can plug that down n plus 1 to the front and log 3 by its own, and you get the massive log of that. And divide both sides by log 3, and log 3, if you check, is a positive number, so you do not need to flip the sign. So n plus 1 is log of 2,003 divided by log of 3, and therefore n is larger than log of 2,003 divided by log of 3 subtracted by 1. This is the expression given by the paper. Now solve for n, which is just simply calculator. Log of 2,003 divided by log of 3 gets you about 13 or so, subtract by 1 gives you 12.2, and so n is larger than 12.206. And because generation cannot be a decimal, it must be a whole number, and the closest whole number that is larger than 12.2 is 13. So n is 13. So part 4, instead of having 3 descendants per generation, we have 2. And we need to compare how many fewer descendants that would give. So let's start with our original answer of 2152359. That is the sum to 15 of our of 3 per generation. So 3 to the n, 1. Subtract that by the sum to 15 of 2 per generation. Now, how do we find that? So we know that A, once again, is just 2 because it starts off doubling, and R, again geometric, is also 2, and therefore the sum to 15 of 2 to the n is A, which is 2, times 1 minus r, which is 2, to the n, which is 15, divide by 1 minus n, 1 minus r, which is 2. So it is a minus 2 times 1 minus 2 to the 15, and put that into the calculator. 2 to the power of 15, subtract by 1 times 2 is 65,534 descendants. And by subtracting the original 3 per generation by 2 per generation, we get 2152339. Subtract by the answer yields you a difference of 21457825 descendants. And that is it for this paper. So overall, this paper is quite a tricky one because of all the different wordings, especially for section A. It's a bit cruel, to be honest, for the example to ask these kind of questions all on the same paper. It would be a bit more fair if it's spread out for, say, 2 or 3 years. But that's what examiners love to do. And if you can understand the notations or wordings, then that's how you prove you are an A-star student. So yeah, that's it. Hope you've learned something, and I will see you on my next one.